and welcome. The sum of three terms in arithmetic progression is 12, and the sum of their squares is 66. Find the numbers. That is, our task is to find the three numbers that forms a sequence known as arithmetic progression or arithmetic sequence. That is a sequence whose terms increase or decrease by adding or subtracting a constant number, okay, throughout. Okay, so then B, our task is to find the increasing arithmetic progression whose sum of the first three terms is 27 and the sum of their squares is 275. Okay, so for the first question, okay, we're asked to find three numbers that forms an arithmetic progression. Okay, and these three numbers, when added together, their sum will be 12 and the sum of their squares will be 66. Okay, now let's find out. So for three terms in AP, okay, that is for three terms in AP, we're going to have A minus D, A, and then we have A plus D to form the sequence known as arithmetic sequence or arithmetic progression. Okay, so the first statement we have in the question is that the sum of the three terms is 12. So which means sum, when we add this together, A minus D, okay, plus A plus A plus D, this is equals to 12. Okay, now let's add what we have here. So A plus A plus A is 3A minus D plus D, that will be 0. So 3A is equals to 12. So if we divide both sides by 3, we're going to get A to be 4. So the value of A, that is the first term, is 4. Okay, all right. Then also, we are given that sum of their squares. So which means sum of squares. That is sum of the square of A minus D, okay, A squared, and also the square of A plus D is equals to 66. So sum of their squares, that is the three numbers that forms the arithmetic progression. So squared of A minus D plus A squared plus A plus D, that's plus squared of A plus D is equals to 66. Now let's find out. Already we know that the value of A is 4. So I can just say this will be 4 minus A raised to the power of 2 plus 4 squared plus 4 plus D, okay, then raised to the power of 2, that is bracket 4 plus D raised to the power of 2 equals 66. So if I expand this, I'm going to get 16 minus 8A minus 8D, okay, minus 8D plus D squared, okay, then plus 16 plus 16 plus 8D plus D squared equals to 66. 16 plus 16 plus 16, that will be 48. Negative 8D plus 8D, that will be 0. Then D squared plus D squared, then we're going to have that to be 2D squared equals to 66. So what to do from here is to move 48 to the right side of the equation, that is to isolate 2D squared. Okay, so it means that I'm going to carry this over to the right side of the equation. So we are going to have 2D squared on the left hand side to be equals to 66 minus 48. So that 2D squared will be equals to, this should be, okay, 18. All right, 18. So if we divide both sides by 2, we have D squared to be equals to 9. So that D will be square root, plus or minus square root of 9. Then D will be plus or minus 3. So which means the common difference is either plus 3 or minus 3. But we can verify. Now we have that the sum of three terms or the sum of three numbers that forms a sequence known as arithmetic sequence, also known as arithmetic progression, is 12, and the sum of their squares is 66. So which means, let's verify. Let's verify. So we have a to be equals to 4. Okay, so when d is equals to positive 3, then we're going to have, we have a minus d, then a, and then a plus d to form the sequence. So this will be 4 minus 3, 4, then 4 plus 3. So this is 1, this is 4, and this is 7. Okay, let's add them together. Sum, we then have 1 plus 4 plus 7. This will be 12. 7 plus 4, okay? 7 plus 4 is 11 plus 1. That will be 12. Then we also have that we have sum of squares. For sum of squares, we have 1 squared plus 4 squared plus 7 squared. Okay, 1 squared is 1, 4 squared is 16, 7 squared is 49. So 16 plus 1, 17. 17 plus 49, this will be 66. Also, when a is equals to 4, and then we have d to be minus 3, then we have that the sum will be 4 minus negative 3, which is the first term, a minus d. Then we have the second term to be a, while the third term is 4 plus minus 3. So this is 7, this is 4, why this will be 1. So we have it in descending order, okay? We have it in descending order. So in this case, we know that when we add 1, that's 7, 4, 1. 7 plus 4 plus 1. Okay, this will be 12. Then also sum of squares. Sum of squares, which is 7 squared plus 4 squared plus 1 squared. Then this will be 66. So this is verified. This is also verified, like that. All right, the second question. We're asked to find the increasing arithmetic progression whose sum of the first 3 terms is 27 and the sum of their squares is 275. So it means that we can again use this, that is to form the arithmetic sequence. Okay, that is the arithmetic progression. You can see that the numbers are increasing. Okay, that means the numbers that form the arithmetic progression, okay, the numbers are greater than 0. So that means they are increasing. So no one of the, or that's no one, not one of the 3 terms is negative. Okay, so which means that in this case we're going to have, so we know that for increasing arithmetic progression, okay, for increasing arithmetic progression, we're going to have a minus d, a, then a plus d. That will be 1, 4, 7. Okay, now, but in this case their sum, okay, sum will be a minus d plus a, then plus d is equals to 27. That is, the first 3 terms that forms the sequence are a minus d, a, and then a plus d. All right, so in this case, let's add this together. We have a plus a plus a. This will be 3a. Then this will be negative d plus d. That will be 0. Okay, so 3a is equals to 27. So if we divide both sides by 3, the value of a will be 9 in this case. For the first one, we got the value of a to be 4. But in this case, the value of a is 9. Okay, all right, so next, we're also given that the sum of their squares is 275. So sum of squares, that will be squared of a minus d plus a squared, then plus squared of a plus d squared, okay, equals to 275. Now we have the value of a to be 9, so it means that this will be 4 minus d raised to the power of 2 plus, that is 9 minus d raised to the power of 2, then 9 raised to the power of 2 plus 9 plus d raised to the power of 2 equals to 275. So if we expand this, this will be 81 minus 18d plus d squared. Then also this will be 81, then plus 81 plus 18d plus d squared, and this will be equals to 275. Okay, it will be equals to 275. So in this case, 81 plus 81, that will be 162. So 162 plus 81, okay, this will be 243. So we have 243. So negative 18d plus 18d, that will be 0. So that d squared plus d squared will be 2d squared equals to 275. Then I'll move this to the right hand side so that 2d squared equals to 275 minus 243. So that 2d squared will be equals to 5 minus 3. That will be 2. Then 7 minus 4, that's 3. Okay, then we have this to be 2 minus 2, that's 0. So dividing both sides, okay, by 2, dividing both sides by 2. From here, we then have d squared to be equals to 16. So that d will be plus or minus square root of 16. Then the value of d will be plus or minus 4. Okay, so the common difference is plus 4 or minus 4. So we can verify. Okay, let's verify. Let's verify. So in this case, okay, we want to verify. Okay, the first term is 9. The common difference is plus 4. Okay, so we have sum of the 3 terms in AP. You know, we have a minus d, then a plus d as the terms that forms the arithmetic progression. So this will be 9 minus 4, this will be 9, and this is 9 plus 4. This will be 5, 9, then 13. Now, their sum, we then have 5 plus 9 plus 13. 5 plus 9 is 14. 14 plus 13. This will be 27. Verified. Okay, sum of squares. Sum of squares. So that means 5 squared plus 9 squared plus 13 squared. This is 25. This is 81. This is 169. Okay, 169 plus 169 plus 81. 1 plus 9, that will be 0. That's 10. Write 0, carry 1. This is 14. That will be 15. Carry 1. This will be 250. Then plus 25. Then this will be equals to 275. Verified. The noblest pleasure is the joy of understanding. Bye-bye.